So I know we've had some lengthy videos recently, but this should shorten things up a little bit. We're going to talk linear and rational equations. Linear equations we've been doing probably since seventh and eighth grade. Rational equations, probably in Algebra 1. So to start this problem, we're going to distribute where we can. We have 2 minus 5x minus 8 equals 8x plus 28 minus 15x minus 12. Combining like terms, I have negative 5x minus 6, and then a negative 7x and 16. Bring all the x's to one side of the equation. I'd rather have my x's positive. So in that case, we end up with a 2x. And on this side, we end up with 22. So x equals 11.
Now we involve fractions. Now there's a couple ways to look at this. I'm not a huge fan of fractions. I can work with them no problem. But if I can get rid of fractions, I will. Now in this case, I don't think it's prudent to necessarily get rid of them right in the beginning. So what I would do is I'd go ahead and just distribute each of these two terms. Like I said, I can work with them. Just not super fond of working all the way through a problem with them if I don't have to. So we've got a third x here because the 2's reduce, 9/4 here, 6x here, and equals x plus 7. So now what I would do is I would get rid of my fractions. And what I do is I look at every single denominator in the entire problem and then multiply by the common denominator of the whole problem, which in this case is 12. It's a little bit similar to what we did in our complex fractions. So then I go through and I give every one of these numbers on both sides of the equation a multiple of 12. So this guy reduces to a 4, so I have 40. Second one reduces to a 4 as well, and I have 4x. Third one reduces to a 3, and 3 times 9 is 27. 6 times 12, 72. 12 times x is 12x. 12 times 7 is 84. And then combine like terms where you see them. I've got a 68 x here, and I've got a 67 here. Keep the 12x plus 84 on the other side. And then I'm going to bring the 12x over by subtracting. I'll get a 56x. And then I will subtract the 67 from the 84 and get a 17. Whoops. 17. Divide by 56 to both sides and get 17 over 56. A little bit tough to check, but you could do it. So this next problem is very similar to the last, other than the fact that we don't have any multiplications to do. I've got fractions, but no multiplication, so I'm just going to go ahead and try to find my LCD right now. Now, if I look at all the factors of these terms here, I've got 3 2's in the 8. I've got a 2 and a 5 in the, oops, sorry, I have a 5. And then I have a 2 and a 3 from the 6. So, the 2's need a 2. The other 2's need a 4. And then I've got a 5 and a 3 left. So in this case, I've got what appears to be 20 times 6 or 120 is my LCD. All right. And if I take 120 and divide that by 8, that's going to get me 15. 120, and I divide that by 5, and I'm going to get 24. $120 divided by 6 gets me 20. And then 120 times 1 is 120. And then I've got my fractions disappeared. I take and distribute what I can. 24x, positive 48, 20x and 20. Subtract 120. a negative 9 here, and a 48. On this side I have 20x, and negative 100. Bring the 100 over, so that's 148. Bring the 9 over, that's 29. Divide 148. Divided by 29, I don't believe that goes into it. So that would be the answer. All right, so now we've got a rational expression, or we have a binomial and a monomial down here, neither of which have anything in common, again, because of this plus. So I have to, again, multiply everything in the problem by the denominator that's the lowest in common in both sides, which would be an x and an x plus 2. Distribute that to the three terms, 1, 2, and 3. In this first term here, my x goes, so I'm left with an x plus 2. Second term, the x plus 2 goes, so I'm left with an x squared. And the third, I have an x squared plus 2x. So now we've got a quadratic. I get rid of the x squareds on both sides, and now I no longer have a quadratic. It's just a linear equation. Bring the x over, and x is equal to 2.
Our last examples requires that we take in factor first. So we'll have x plus 1 and x minus 1. And then we find a common denominator of both sides, which is that value of x plus 1 and x minus 1. And we distribute that to each term, and hopefully we will reduce all of our denominators. So now we have 2x plus 3 and x plus 1 minus 2x minus 3 times x minus 1 equals 10. Next, we'll FOIL these terms out. So we have 2x squared plus 5x plus 3 minus, put that quantity down, 2x squared minus 5x plus 3 equals 10. I'll distribute the negative through. 2x squared plus 5x plus 3 minus 2x squared plus 5x minus 3 equals 10. And then it appears we still have our 2x squared. I have 5x and 5x, which is 10x, minus the 2x. Let's clean that up. I lost that, which is 8x. And then the 3's go. So that's equal to 10. Next, I'll just take and divide by 2. So I have x squared plus 4x, and that's a 5, but I'll bring it over, and that subtraction is equal to 0. This is going to factor to x plus 5, and x minus 1 is equal to 0. So therefore, I have negative 5 and 1. And it turns out 1 is an extraneous value because if we plug it back in, we get an undefined 0 value there. And that's it for today. See you next time.